Hey guys, so today we are going to talk about multiplying fractions, and we are going to continue basically what we've been doing. Now we are just moving into multiplying fraction times fraction. I have my little assistant here, Dirks. He's going to help me teach you guys how to multiply two fractions together. We are going to start first with models, and then we're going to talk about what would be the standard algorithm for how to solve these. So for the first problem, we're going to start off really easy with two unit fractions. If you remember correctly, a unit fraction has a numerator of 1. So the first problem that we are going to start with is going to be 1/2 times 1/4. And we want to model these fractions first and then talk about the standard algorithm. So whenever I go to model this problem, the first thing that I'm going to do is draw one model because I'm starting with 1/2. 1/2, we should know at this point, is less than 1. So that's the first thing that I have to model, is I have to model what 1/2 looks like. Anytime I model multiplying fractions, I like to have two different colors here to do it with, just because it makes it easier for what we're going to see on how you find the answer. So I'm going to make my rectangle into 2/2 here, and I need to shade in what I have. I have 1/2 here. So I'm going to shade in 1/2. Okay. Now, I need to take my model and break it up into fourths. This way, I'm going to do this horizontally. So, for me, I'm going to break it in half first, and then break each of those halves in half, which give us fourths. And then I need to shade in 1/4. So, I shade in that 1/4 of a piece. Now, my answer is shown right here on this model. My answer is going to be in the overlapping section of shading. So that one piece right there is going to represent my answer. 1 is going to be my numerator. The denominator is going to be the number of pieces it is out of. 1, 2, 3, 4, 5, 6, 7, 8. So my denominator is going to be 8. As you guys can see, if we use the standard algorithm with multiplying two fractions, all we have to do is numerator times numerator. That gives us our numerator of the product. Denominator times denominator. That gives us the denominator of the product. Okay? Let's try another one of these that are using unit fractions. This time, I want to use the problem 1/3 times 1/3, and we're going to show what this one looks like on a model. Again, first thing, I'm going to want to just start with one model. So I'm going to go ahead here and draw out my one model. Then that one model is going to be split into thirds, so into 3 pieces there. I have 1/3, so I need to shade in 1/3. Dirks likes watching my marker on the whiteboard. Then I need to shade in horizontally thirds again, or I need to create thirds horizontally. And I need to shade in one of those thirds. Again, my answer can be found in that overlapping section. There's one piece shaded in both brown and blue. Therefore, that is my numerator of my answer, 1. The denominator is the total number of pieces inside the model. 1, 2, 3, 4, 5, 6, 7, 8, 9. Denominator there is 9. Therefore, the answer is 1/9. If I follow standard algorithm, 1 times 1 is 1. 3 times 3 is 9. Should have used blue, sorry. So therefore, I would get 1/9. All right. Step it up a notch. Let's take a look at a little bit more challenging problem. So this time, let's use the problem 2/3 times 3/4. All right. Same thing goes for this problem. The first thing I have to do is start with my 2/3. So I'm going to draw one model. And I need to break that model up into thirds to represent my 2/3. This time, instead of just shading one of the pieces, I need to shade in two pieces because I have 2/3. Then, horizontally, I need to shade it, or I need to split it into fourths first. I have to shade in this time 3/4. So I'm going to shade in 1/4, 2/4, 3/4. Now this time you'll see I have a lot more overlapping than just one piece. So I need to carefully count how many pieces are overlapping in blue and brown. I counted 6 pieces. That represents the numerator of my fraction, and the total number of pieces in my model represents my denominator. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 is my denominator. If you look at solving standard algorithm, 2 times 3 is 6, 3 times 4 is 12. We should all know at this point that 6/12 can be simplified if I know that both of those numbers are divisible by 6. 6 divided by 6 equals 1. 12 divided by 6 equals 2. Therefore, I get a final answer there of 1/2. Okay? One more problem before we move on to our next activities. Let's do this time 1/2 times 4/5. Now, you guys are probably catching on to this so quickly that you guys can just look at this problem and already know what the answer is. But remember, in 5th grade, you still have to be able to identify the models and show that you know how to model. So, with this one, I'm going to start again by creating my one model, split it in half, shade in half of it. Horizontally, I'm going to split it into fifths. And I need to shade in 4 of those 5 pieces. So 1, 2, 3, 4. Okay. Now, this time I'm counting how many pieces are overlapping and shading. 1, 2, 3, 4. Therefore, 4 is my numerator. 1 times 4 is 4. The total number of pieces in my model is my denominator. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And therefore, I get 10 as my denominator. 2 times 5 is 10. This fraction, 4/10. Well, I know that 4/10, both 4 and 10, are even numbers. So therefore, I am able to divide both of those numbers by 2 because they're even. So 4 divided by 2 is 2. 10 divided by 2 is 5. That means the answer here is 2/5 in simplest form. Now, today you guys are going to be reviewing skills that you already know. This week, we're going to continue to talk about this and practice this skill as well as work on word problems as well. It's important for you guys to remember, I know I've mentioned it several times in class, but we are going to look at problems that deal with the word of, and that word's actually going to mean to multiply. So look forward to that the rest of this week, and if you have any questions, please feel free to reach out or message me in Canvas.